Hey, this is Don from Padlock Technologies again with another video. A quick video. Got the question: distant vector versus link state protocol, EIGRP versus OSPF or ISIS. I'm going to move ISIS out the way on this question because really this is a campus LAN design question, and it's really, should we use EIGRP or should we use OSPF as our routing protocol? So let's talk about distant vector, right? So distant vector is basically routing by rumor. It's reachability information only. It is not topology information. So if we look at the board here, we have EIGRP. What's the benefits of this? Well, it's ease to implement, right? It's real easy, right? Ease of implementation, right? And when I say routing by rumor, let's say you have a router here, triangular fashion router here. Let's say you have a router here, right? So EIGRP, like I said before, is clearly just reachability information. There is no topology information like in OSPF or ISIS. So I only know about the routes and networks that my neighbor knows about. So if 1.1.1.1, and that would never be something internal, but just say, for example, if that's getting advertised out to here and here, well, obviously they're going to advertise it to here. So I know. And this is probably going to be equal cost multipathing because depending on the metric, let's just say everything is even. I can either go this way or I can go this way. Okay. Now, if you do unequal cost load balancing, you're going to have to do something called variance. All right. Now, the variance come in, whatever number you put in it multiplies that, or as that, I'll say multiply that to the feasible distance. And then you can, let's say this was, let's say this was 5. So from here to here is 10, but this was 10 and 5. Here to here is 15. Obviously, it will pick this way to go, right? Unequal multipathing, unequal cost multipathing, or load balancing, so to speak. What you would do is they have this thing, this called reported distance and feasible distance. Feasible distance is the complete path. Reported distance is the path to is the distance reported closest to the destination. These are both 5, right? So this is technically a feasible distance of 10, technically a feasible distance of 15, but because the reported distance is 5 and 5, that means that this router, let's go with, yeah, that means that this router is closer to this destination. All right. So 5 is less than 15. So if I did the variance command, I could technically put this route in. All right. And EIGRP is the only protocol that can do this. Right. OSPF cannot do unequal cost load balancing. Right? Because there's no variance command in OSPF. But yeah, JRP can do this. Now, what are some of the pros? What are some of the cons? Well, one of the big ones here is stuck inactive, right? And this can cause a real problem in your network, right? If you have auto summary or something like that on, right? So what happens is if a router loses a route, it sends a query out, and then it got to wait for a reply. Now, the way you're going to beat this is, especially if you're using like DMVPN or something like that, you're going to have to do, you can either do EIGRP stub feature, so EIGRP stub, EIGRP stub feature. Now, there is another feature in stub feature called a leak map that you can use if you want to leak specific route, because when you do EIGRP stub, you're only going to get connected routes and summarized routes, or you can do summarization. That's how you tackle this little issue here called stuck inactive. Benefits of EIGRP. This is the major con, right? Stuck inactive stuff is the major con. Major benefit though is summarization. You can summarize anywhere in a network. Now, there's some things that doing summarization will do, right? Because if you do summarization, it also puts it in a null route. So let's say if you had quad zeros that you summarize down, right? You say you summarize quad zeros from this router here, you summarized it down to this router for some reason if you wanted to do that. Well, in the routing table, this quad zero is technically a null route, right? Now you can do summary route poisoning, which let's say if you have BGP on the back end and you were getting quad zeros from there, well, the static route's going to take over because static routes have a lower administrative distance. But what you can do is you can poison the summary route to say, hey, the distance of this summary route is 255. And then I will still send the summary route down to the other router, but that BGP route that's giving me the quad zeros that's legit will actually be in the routing table. So you will not black hole traffic when you do a summary route. But again, the benefits of this is strictly I can summarize everywhere, ease of implementation. I don't have to worry about areas and certain rules that are in link state protocols, and that's it. So let's talk about link state protocol OSPF. So let's talk about OSPF. So OSPF has a hierarchical design to it, right? Now, I'm going to say something that may be a little controversial, right? So you have area 0, right? So area 0 is here. 0, 0. Now everything has to be connected to area 0. So if you got area 1, area 2, area 3, right? And let's do that. Now you have different type of areas, but they're really like subsections of areas, and we'll talk about that. Now, within the area is reachability, and topology information. Okay, within area. When it goes outside of the area, it is only reachability only. That means area 2 knows nothing about what's going on in this area and vice versa. So it kind of acts, and this is where the controversial part comes in. It kind of acts like a distant vector protocol, which is routing by rumor, when it leaves an area, because I'm only sending you reachability information. I'm not sending you topology information, right? Another thing is summarization. Summarization can't be done everywhere in a link state network like OSPF. You can do summarization at the ABR. So there's a router over here, router over here, router over here. You can summarize there. Now, where are you going to summarize into area 0 or out of area 0? You summarize into area 0. There's no point of summarizing an already summarized route, right? So if you try to summarize from area 0 into area 2, it's kind of pointless because it's already going to be summarized when it leaves area 0 going into area 2. So if you want to summarize, you summarize from the area going into area 1. I mean, into area 0, right? But you can only do that at ABR. And then let's say this is area 5 over here. This area was connected to, let's say, EIGRP over here somewhere. If you wanted to redistribute your EIGRP routes in the OSPF, this area now has to become an NSSA, not so stubby area. Why? Because when you do the redistribution, this will redistribute those routes into the NSSA as a type 7. So this is a type 7 LSA. And this is where you have to know your LSAs. So you have and this is not OSPF v3. So we're not talking about IPv6 that has 8 and 9, which is again, your local link and then your prefix LSA. And then if you're talking about MPLS-TE, there is LSA-10, but we're not even going to talk about that because we're not talking about MPLS-TE. So if we run down the LSAs, you have type 1 router LSA. Type 2 is a network LSA. That's only if you're going to have a broadcast network. Say you have a switch in the middle and you have a bunch of routers connected to it. If you just turn on OSPF, which is default, is going to be broadcast, it will do a summary not a summary LSA, but a network LSA, because you're going to have this thing called a pseudo node. And the pseudo node is there because OSPF doesn't understand anything other than point to point from an algorithm standpoint, right? It doesn't really understand that, hey, I have multiple routers in a switch in the middle. So what that pseudo node does is it forms point-to-point connections to it. Everybody connects to that, right? So that the SPF protocol can actually read the graph. So that's the whole purpose of that, right? This whole purpose of the pseudo node is because of that. The pseudo nodes in ISIS as well, but that's if you're using broadcast. If you're doing point-to-point, then you don't have that BDR, DR election, none of that stuff. So you don't have to really worry about the pseudo node. Type 3, so let's say 1 and 2s are always going to be within the area. So 1 and 2s in the area. Type 3s is a network summary LSA. So that goes out. Type 3s will come in and be summarized. So you'll see 3s from, ABR going in, 3s, right? 4 is an ASBR LSA, which is generated by the ABR, right? So if you have a domain outside of the network and you redistribute it, well, I need to know. And the type 5 LSA, which I'll explain over here in this section when we get to near type 5, which is the next one up, the forwarding address never changes. So if you look, this is where you need to know how to read the OSPF database and, get really in depth and know what a forwarding address is and stuff like that. So the forwarding address never changes, right? So in an external route, forwarding address is really in type 7, but we'll just disregard that. Let's just get to the LSAs. So when you do a type 5 route, it's kind of like how EBGP and IBGP works, where the next hop never changes, right? So when that type 5 gets down to the ABR, to the ABR, when it gets down to the ABR automatically generates the type 4 because you don't know how to get to the other area. That's a type 5. You don't know anything about that, right? So usually the forwarding address is going to be quad zeros, which means go to your ASBR to do that, or go to your ABR to do that, right? So you can't have a type 5 without a type 4, right? So if you get an external route, as soon as it hits the ABR, it generates and say, hey, because it's going to have the next hop is going to be wherever that came from and whatever that router is. And then internally, you don't know how to get there. So then the ABR has to tell you, well, I know how to get there, so you need to come to me. So that's the whole purpose of the type 4 LSA, is to tell you how to get to the ASBR, which is basically going to be through the ABR. Type 5s are your internal or your external routes, right? So if you look at OSPF, best path selection is intra-area routes, which is going to be intra-area. Inter-area routes, E1s, E2s, N1, N2s, right? So external ones, which has all the metrics in it. E2s are just get me out as quick as possible. N1s is not so stubby area. N1s is the same as a E1, but it's just in a not so stubby area. And N2s are just, E2s, just in a not so stubby area. The default for external routes or type 5s are going to be type 2 routes or metric type 2s, right? Type 1s are more preferred over type 2 routes. because it has the complete metrics in it. So that's why it's more preferred. Same thing with N1, N2. Type 6, nobody really uses. Like, I think that was group memberships. And then type 7 is what happens when you redistribute into a not so stubby area. So you redistribute as a type 7, but when it leaves the NSSA area, it turns into a type 5 route. So it turns into a type 5 once it leaves the NSSA. Now, you can, now say there was 2 routers, you can actually say, hey, let's say you can say you can actually translate to type 7. So you can actually go in there and say this router can translate the type 7 to type 5 to 5 if you wanted to do that. Now, in the real world, you're not going to do that. In the CCIE exam, you may be asked to do that. So this is where it's a technology exam. It's not a best practice exam. Do you know the tech? So if they say something like, hey, we want router 2 in the NSA to actually do the or we want router 2 in area 5 to translate the type 7 to type 5 and not router 3, then you need to know that you need to go into router 2 and use I think the command last time I checked was area, whatever the area number is, NSSA translate type 7, and then that's it. You can also do suppress forwarding address to just make it quad zeros, but most people are not going to do that because the forwarding address was put in for things like if you had multiple paths to get somewhere. So again, what is the con of OSPF? Well, now you have to be very careful in your design because again, you cannot summarize everywhere. Everything, you have the rules. Everything has to be connected to area 0. You cannot summarize everywhere. It has to be at the ABR or the ASBR. You have to worry about LSA flooding, right? You can run incremental SPF as well for like if a certain piece of your intra area breaks, you don't have to run the whole SPF algorithm on everything, right? You just run it on that broken piece. Every router is the root of the SPF tree. So when they do their SPF calculations, they are the root, unless you're doing something like reverse SFP or SPF, which is running the SPF algorithm from another router's point of view, which is a technique that's used in optimal route reflection. I did a video on that as well. You check the video, optimal route reflection, just type it in, you'll see what that's all about. CSPF is MPLS TE based because that's constraint SPF, incremental SPF. Again, I just said it was based on a break in within the intra area. If something breaks, you can just run the SPF algorithm on that. So there's a lot of different algorithms, SPF algorithms that can be ran. The other thing is you can do certain things that you got to be careful because one of the rules is everything got to be connected to area 0. So if you mess up and you connect area 2 to area 1, which is connected to area 0, now you got to do something called a virtual link to basically fake it like you're connected to area 0. That is not something that you need to do. That is not a good design, right? If you have to use a virtual link, bad design off the rip, right? Redesign everything so that everything is connected to area 0. Area 0 should be layer 3, like your core network. If you're going to do OSPF, you would break these out in pods. So let's say this is pod, right? And then here would be the all L3 core here, right? If you can afford that, like long as it's not a CapEx hit while buying the extra equipment, you would have area 0 be an all L3 core. And then you'll have, your distribution layer or something like that somewhere up here. And then those will just be connected in different areas if you're going to use switches for it. If you're not going to use switches or anything, then you'll just have a router switches down here and then that can get up in there. It's all really depends on, what is the equipment? Are you doing collapse core? Are you doing 3-tier hierarchical design, basic LAN campus design kind of stuff? That's what you would do with OSPF. Pros is fault isolation. So if something goes down in area 1, does not affect area 2 or 3 other than reachability information. So let's say you got an LSA flood, something really wonky is going down in area 1. Area 2 and 3 will still function as long as it's not trying to reach area 1. If it's trying to reach anything in area 1, obviously if those routes are flapping and they show up in the route table and they don't show up in the route table, you may have some problems there. But if you guys are all going to a different spot and you're not actually going to area 1 for anything, then whatever's going on in area 1 doesn't affect area 2 or 3. Whereas in EIGRP, there is no fault isolation. So if something goes wonky in your EIGRP domain, it can affect everywhere in your environment. So that's another kind of EIGRP. So those are the two. That's the difference between EIGRP, OSPF. Broad overview of the difference between the two. What should you choose really is based on your level, how comfortable you are implementing either of the protocols. You need to know the pros and cons, kind of went over that a little bit. Again, ease of implementation. Link state protocols is going to force you to think a little bit more from a network design standpoint, right? Because of those limitations, that things that you cannot do, based on the link state protocol and all that good stuff, and based on just the general rules of OSPF and the link state protocol, you're going to have to think your design a little bit through, right? Oh, if I got, firewalls, well, this area is going to have to be in an SSA, because if I need to redistribute my quad zeros down, well, I can't do that in a normal stub area or a totally stub area. I can't do that. So I'm going to have to make this area a not so stubby area so I can redistribute those quad zeros down. Well, technically you wouldn't redistribute quad zeros. You would just do a default originate in the NSSA area. EIGRP, very quick. You get EIGRP up and running super quick, and this vector protocols are recommended if you're going to do something like DMVPN. So EIGRP, BGP is not a distant vector protocol. It's a path vector protocol, but EIGRP and BGP are the recommended protocols for something like DMVPN. If you're going to go down the DMVPN Flex VPN route, you know me, I'm going to say do SD-WAN and forget all of this, right? Go OMP routes, T-locks, and all that good stuff. Single management, decouple management, and orchestration, data plane, all that. Decouple it. You don't have to worry about any of this. But if you're going down the DMVPN Flex VPN route, EIGRP, DMVPN. If you are a small network, you can get away with EIGRP. But once you get into these large campus networks, you're probably going to be better off with OSPF because of the fault isolation, right? Because, hey, I can say this building is area 1, this building is area 2, this building is area 3. Then I have another pod that's my internet, right? That's my internet pod. So that's going to be an NSSA area. And then I have my WAN area that could be not, well, depending on if you're going to run OSPF all the way to the other areas, that could just be a normal area, so to speak, if you're going to extend it. Now, if you're going to go from a WAN standpoint all the way up to 2 routers and run BGP through DMVPN or something like that, well, then that has to be an NSSA, because you're going to have to redistribute BGP in the OSPF so you can actually get to the branch offices, like if you have a data center or something like that. But again, that's all design, right? You got to look at your design first before you pick your protocol. What are the things that you need to do or need to accomplish? And then you map the routing protocol that you want to use against that, right? Whatever constraints you have, then map it. So this is Don from Padlock Technologies. I hope this answered your question. Don't forget to share, comment, like, and subscribe. If you are someone that's building out a new network, need help on a network infrastructure project or something like that, it's going to be a link in the description below. Click that. Let's get a discovery call so we can talk about what constraints you have, what kind of design you're looking to get, and then we can make sure you avoid some critical mistakes in your design, because if you do make those mistakes, the only answer is you need to redesign your network. And that is the last thing most people want to hear when they have a mistake. So let's catch it before you actually implement it. This is Don from Powerlock Technologies again. Thank you and have a nice day.